How can something smaller than an atom produce enormous power? Nuclear fission releases energy from atomic nuclei, and millions of controlled reactions transfer that energy into heat, steam, and finally electricity.
In 1954, a small Soviet research facility near Ob became the site of a historic breakthrough, the first nuclear power plant to generate electricity for a public power grid. Scientists wanted to demonstrate that nuclear fission could produce useful heat and ultimately generate electricity on an industrial scale. At the heart of the plant was a reactor, where controlled nuclear fission released enormous amounts of heat. When a uranium nucleus absorbs a neutron, it can split in a process called fission, releasing energy and additional neutrons. The chain reaction had to remain controlled. Neutron-absorbing control rods allowed operators to regulate the reactor's power. The energy released by fission was converted primarily into heat, raising the temperature of the reactor's coolant. That heat was transferred to water, producing steam that could be used to drive a turbine. The steam's thermal energy became mechanical energy as it pushed through turbine blades, causing the turbine shaft to rotate. The rotating turbine drove a generator, where electromagnetic induction converted mechanical energy into electrical energy. The electricity was then transformed to suitable voltages and supplied to the electrical grid, demonstrating that nuclear heat could become practical electricity. In June 1954, the Obninsk plant began producing electricity for the grid. This marked a major milestone in the history of nuclear energy. Obninsk was modest compared with later commercial reactors, but its importance was enormous because it demonstrated the practical possibility of nuclear-generated electricity.
The experience gained at Obninsk contributed to the development of larger nuclear power technologies and helped establish nuclear energy as a major field of engineering.
The project provided valuable operational experience in reactor physics, heat transfer, control systems, radiation protection, and nuclear engineering. Nuclear fuel demonstrated that extremely small amounts of fuel could release enormous quantities of energy through nuclear reactions, fundamentally changing energy technology. What began as a pioneering Soviet experiment became part of a global technological transformation, with nuclear power eventually generating electricity in many countries. Obninsk was more than a power plant. It was an early demonstration that the energy locked inside the atomic nuke to electricity, and it helped open a new chapter in the history of human technology.